Hi everyone, welcome back to Eve Math Tutoring. Today's lesson is on the sine curve. So when you're asked to graph the sine function, what you'll do, so say we want to graph y equals sine of x. So you're going to draw an xy chart or grid. And then here you've got 0, 1, and negative 1. And over here you've got pi over 2, pi, 3 pi over 2, and 2 pi. Okay. And these here are in radians. And you can also write the equivalent degrees if you want. So you can, for the x-axis, for the y-axis, we use numbers when we're graphing trigonometric functions. And for the x-axis, we use radians, and sometimes we use degrees. So as you know, pi is equivalent to 180 degrees. Therefore, pi over 2 is equivalent to 90 degrees. 3 pi over 2 is equivalent to 270 degrees. And 2 pi is equivalent to 2 times 180. So I could just write that down, that pi is equal to 180 degrees. If you remember that, then you can easily convert between the two. 2 pi is equal to 360 degrees. So, okay, and these ones here are obviously in degrees. So, okay, so the first thing you want to keep in mind here is the period of the graph. Now, first of all, let's graph the sine of x. So what you do is put a dot at 0, a dot over here, a dot here, a dot at -1, and then a dot at 0 again. And then you just connect them with something like that. So, and the period of this graph is given by this one cycle of your function along the x-axis. So in this case, the period of our y equals sine x function is equal to 2 pi, or also referred, or we could say 360 degrees. Okay, so the period is equivalent to the x distance of one cycle of the graph. So the distance of one cycle of the graph, and then the amplitude is half the difference between the greatest and least value of the waveform. So in this case, our amplitude, so our whole, as you can see, the whole wave goes from -1 to 1. So our amplitude would be half that distance. So amplitude is equal to 1. Amplitude equals 1. So that is, the amplitude is this distance right here. Okay. So that's how you would graph the general sine function. Now, if you're asked to say graph something a little bit different, so say we have to graph something like y equals 3 sine x, then in that case, what happens is this becomes x and y again, and you have the same things over here. So we've got pi over 2, pi, 3 pi over 2, and 2 pi. And then over here we've got 0. Now because this is a 3, now what I usually do is I like to always draw the sine graph somewhere on my page, and it's good to memorize the generic sine function, like the regular sine function, so that when you have other ones given to you, you can graph it from there. So I like to have 1 and 0, put a dot at each one. This dot goes over here, like that, okay? So that's 3 pi over 2. Okay, so this is y equals sine x. So if you want to graph y equals 3 sine x, what you're going to do is put a 3 here and a -3 over here. And when you do that, you can graph that one like that. Okay, so basically all that changes is because of this becomes a positive 3 and negative 3. Okay, so say we were asked to graph something like y is equal to negative 2 sine x. So in that case, what happens is, so this is my y and x. So this becomes a 2, 0, and a negative 2. And then we've got pi over 2, pi, 3 pi over 2, and then 2 pi. So what happens here is because this is negative, now the 2 makes these change to positive 2 and negative 2, so the 2 makes these change, and then the negative actually flips the graph, so your 0 points are still at the same, but over here instead of a positive, like positive 2 or positive 1, like in this case, it flips it upside down, so instead of positive 1 it becomes negative 1, and then the negative 1 becomes positive, so it flips it this way, here and here. So it becomes like this. Okay? So that is y equals negative 2 sine of x. Like that. Now, what if we were asked to, say, graph something like the following? Say we want to graph something like y is equal to sine of 2x. So in that case, we've got y and x. Then we've got, so now in this case, the other one, we had the 2 in front, so that changed the numbers here. But in this case, we've got the 2 inside the function. So y equals sine x, we know that that one looks like this. Okay, so that's y equals sine of x. So pi over 2, pi, 3 pi over 2, and then 2 pi. And then in this case, we've got 0 here. So we've got pi over 2, pi, 3 pi over 2, and 2 pi. So what happens here is this becomes, okay, so what happens is instead of having one cycle, you end up getting 2 cycles within the same period. So normally within the period of 2 pi, you would have 1 sine. Like in this case, within 2 pi, you've got 1 sine wave. But when there's a 2 here, that becomes 2 of them in the same cycle. So basically what you do is you take the halfway point, which is right here, and we're graphing this function right here. So what you do is you put, instead of putting like, the 0 up 1, like we've got, for the sine graph, you've got 5 points, 1, 2, 3, 4, 5. So in this case, instead of putting the points like above pi over 2, you find the halfway point. You put a point there, so that's at pi over 4. Point here, start at 0, a point down here at in between pi and pi over 2 and pi, and then a point here. So then your graph becomes something like this. And then you get one more of the same thing. So again, at the halfway point here, 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 and here. So now we draw another one. So now here we end up with this y equals sine of 2x. So this is what that would look like. And as this number goes up, you would get more of these within the 2 pi period. So if this was a 3, we'd have 3 of them within this distance. If this, like 3 of these, 3 sine functions. In this case, we've got 2, right? But if this was a 4, we'd have 4 of them. So, in this part here, we'd have 1 here, 1 here, 1 here, 1 here. And I can show you that as well. Okay, so I can do an example of that. So if we had, say, So if y was equal to, let's just use a different color here. So if y was equal to sine of 4x, then that would, now in this region I have 2 of them. So I would go halfway here. Okay, let's see here. So we'd have 1, 2, 3. So we have to fit in. So now, okay, so what you would do then is divide your graph into 4 parts, or your x part. You would divide it into 4 and then fit in a sine curve within each one of those points. So in this case, we divided it in half. Now we put 2 sine curves. So that would mean we have to have 1 sine curve here, 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 and here. So if this is my whole distance for my sine curve, then I've got to divide that in half, and then I've got to put a point up here and halfway through and 1 here. So then I end up with something like this. So that's 1 sine, and then the same thing over here. A point up here, point down here, and I would go again for my second sine. And then for here, again, take this part, divide it in half, so here and here. So then we'd have another one, and then over here we divide this in half, put 2 points, and then we'd have our function y is equal to sine of 4x. So that's how you would graph the 4x. You'd have 4 of them within that graph, okay? And then if it was 3, you would just take your graph, divide it by 3, and then put the sine functions within there. So you'd have to have 3 of them in the same distance from 0 to 2 pi or 0 to 360 degrees. So we could write those into 90, 180, 270, and 360 degrees. Okay, so now say we were asked something like, how to graph something like graph y is equal to sine of x plus pi over 4. So in this case, we've got something different now. We've got not a number here or here, but we've got something added to x within brackets. So what that does is, when this is a positive, this shifts your graph to the left. So it shifts in the other direction that you would think. You'd normally think if this is positive, it would shift right, but actually it shifts left. And if it was a negative, so if we had x minus pi over 4, so this shifts your graph, shifts left pi over 4 units. Basically, that's what happens here. If it was y equals to sine of x minus pi over 4, that would shift your graph right by pi over 4 units. Okay, so in this case, what we want to do is we want to graph this. So here's y, and here's x, and here's pi over 2, pi, 3 pi over 2, 2 pi. Here's 0, 1, and negative 1. So you can start off with your normal, y equals sine x first. Start off with that. I would normally start with that one. So here we've got y is equal to sine of x, our generic y equals sine x graph, which I think is a good idea to memorize when you're doing trigonometry and graphing. And then, so now what happens is our graph, because it's plus pi over 4, it's going to shift our graph. So now we're going to graph y is equal to sine of x plus pi over 4. So we already graphed this. Okay, so that maybe should have been written in green so it's not confused here. X plus pi over 4. Okay. So this, what happens is it shifts left by pi over 4. So pi over 4 is half the distance between 0 and pi over 2. So basically, all your points shift over by pi over 4, which is half the distance. So what you do is you take each point, so here, normally it's here, and you move it to the over by pi over 4. So each one of my points, I'm just moving them over half the distance, okay? And then you just connect them, and now you've got your graph for y equals sine of x plus pi over 4. You just shifted it to the left pi over 4 units. And if you're wondering where these dots are at, you could write down that this is pi over 4. This is actually negative pi over 4 because you're in the negative area. Pi over 2. Over here we've got pi, and over here we've got 3 pi over 4. And over here, this point here is, so this here, if you want to see what I'm doing here, this is 2 pi over 4, so that reduces to pi over 2. Then we've got 3 pi over 4, and then this here is 4 pi over 4, which reduces to pi. And then we've got 5 pi over 4 as our next point there. This one here is 6 pi over 4, which reduces to 3 pi over 2. Over here we've got 7 pi over 4, and then over here we've got 8 pi over 4, which reduces to 2 pi. So that's how you can see how we got our bottom parts. And again, you can do this with degrees as well. I'm just doing this example with radians, and you can even be given the question sometimes in degrees. So if that was the case, if your question was given to you in degrees, you would want to use degrees on the bottom part. So you can either use radians or degrees when you're graphing, but if you're given, say, x plus, a degree measure here, then what you're going to do is obviously write this part in degrees. So with all that, I mean, you can be given an example where you're asked to, say, graph something and it's got a whole bunch of different things going on. So I'm going to actually do a more complicated example. So say we have something like the following. We were asked to graph something like y is equal to 3 sine 4x minus 2, okay, something like that. So when you get something, say you're asked to graph something like this, so first thing you want to do is pull that 4 out. So I'm going to pull that 4 out, I'm going to factor it out, so this becomes x. So when I divide the 2 by 4, it becomes 2 over 4, which is 1 over 2, okay? So when I look at this now, from here, I can pull out some information here. So now when you're given a graph, an equation, and you have y is equal to a sine bx plus c, so something in this form, this here is the amplitude of your graph, and then your phase shift is given by negative c over b, and then your period is given by not b, but 360, if you're working in degrees, divided by b, and if you're working in radians, 2 pi divided by b. So you can get that information. These are formulas here, okay? So for the general formula, y is equal to a sine bx plus c, a is the amplitude of your graph, b is the number used in some other calculations, and so is c. So to find the period of your graph, you take 360 divided by b if you're working in degrees. If you're working in radians, you take 2 pi and divide it by b. And then your phase shift is negative c divided by b. So whatever these numbers are, you just work them out, okay? And I'll show you how that works for this example here. So what we did first here, so we would work from this part here. So right off the bat, I know my amplitude is equal to 3, and my period for my graph is, I'm going to work in radians, so my period is going to be b divided, so 2 pi divided by b, so 2 pi divided by b, and in this case I'm looking at this one here because it's in this same form before I factor out 4, so it's going to be 2 pi divided by 4 because that's my b value. So that means my period is pi over 2, which means that every pi over 2 units, I should have one graph, one full sine wave. That's what the period means, okay? So if the period is pi over 2, that means every pi over 2, I've got to have a curve, a full sine curve. And then my phase shift is equal to negative c over b, so that's negative, so that's 2 over 4. So that's just equal to 1/2. So that means we're going to be moving 1/2 units to the right when we graph this thing. Okay, so let's just graph it now. So now this part here usually is in, you've usually got like a not a number, but like a radian. Usually a radian measure. Okay, now let's graph this. So we know that our -3. So our amplitude is 3, so we're going to go from 3 to 3. And then we've got 2 pi, so we put down the usual, pi over 2 and 3 pi over 2. Now because this is a 4 right here, I know that I should have 4 of them, 4 sine graphs. Like just ignoring this part for now, I should have 4 of them. So instead of having like 1 going like that, if there was no 4 here, I would just have 1. But because there's a 4, I'm going to have 4 sine curves. So I have my full period here, so and that's also, I also know that because the period is equal to pi over 2 as well. But I just know that because I memorized kind of how to graph these, but you could also figure it out from here too, okay? So then that means within every 0 to pi over 2, I've got to have one sine graph. So to do that, I take the halfway point and I put my dots into play. So here's one sine graph. Oops, that should have gone through the center. And then same thing here, put your dots in, second sine graph, put your dots in, third sine graph, and finally put your dots in and your fourth sine graph, okay? So that's y is equal to 3 sine 4x. And then minus 1/2. So minus 1/2 means you're going to actually shift to the right. You're moving in the opposite direction. It shifts right by half units. And to do that, what you could do is you can figure out, well, first of all, pi is equal to 3.14. So divide that by 2 and get your number. So 1.57. So that means pi over 2 is at 1.57. So 1/2, 0.5. You can eyeball how much that would shift your graph over. And it's shifting to the right by half. So you would just basically move about, so if this is 1.57, then 0.5 is about 1/3 of the way. So each point would move over 1/3 of the way over, and then you would just draw your graph. So it'll be a little bit confusing, but okay, so we moved this one over, that would move over here. So it starts our original graph. And then from there, you want to graph 4 of them within this. So we moved about 0.5 over, and you want to graph 4 of them, 4 sine waves within that same region. So I'm going to try to eyeball this and just graph 4 of them here. 1, 2, 3, 4. So it's kind of getting messy now, but you would obviously do that more carefully, like measuring each one. So this would be this graph right here. So it moves to the right. Okay, so it would be over to the right. So that's a different example, a little bit more complicated. So, so that is graphing sine functions. So I hope you enjoyed the lesson. If I may do a second part to this lesson, I might do some more examples, and then we'll go from there. All right, so I hope you enjoyed the lesson.